Hi, my name is Oliver Foreman. I am a member of Team 43, also known as Aegis. My group mates are Demetrius Sauls, Alex Huffman, Aiden Smith, and Thomas Freeberg. The overall goal for our project is to develop a new technique to protect flash data in the space environment. Now, for a brief overview, radiation is a major concern for any electronics being used. This radiation can originate from space as well as Earth's surface. The radiation from Earth's surface is natural as well as human made, such as airline travel. However, the radiation from space can be categorized into two types of particles: trapped particles and transient particles. Trapped particles are particles that are trapped within the planet's magnetosphere, and these particles are protons, electrons, and heavier ions. For transient particles, these can be categorized into two types: GCR, or galactic cosmic ray particles, and solar events. GCR particles are continuously present, while solar events such as coronal mass ejections and solar flares only have a huge spike whenever there is a solar event occurring. Now to Aiden Smith to discuss flash storage.
Flash storage is a form of solid-state, non-volatile memory, the basis of which is the floating gate transistor. Unlike standard MOSFETs, flash technology has an additional gate between the conventional gate and the substrate. During a write operation, charge can be stored on this floating gate through tunneling. When charge is stored on the floating gate, the threshold voltage of the transistor changes. Read operations therefore actually measure the threshold voltage of the transistor. Both off and on states are given a margin of threshold voltage. In single-layer cells, or SLCs, the range of possible threshold voltages is roughly divided in half, with lower values corresponding to a 0 state and higher values corresponding to a 1 state. Memory density can increase through using multi-layer cells, or MLC technology. In this technology, the range of possible threshold voltages is roughly divided into fourths, so that a single transistor can express 4 possible states. There are 2 common flavors of flash technology on the market. One is NAND technology, the other is NOR technology. So called because the configuration of the transistors resembles the pull-down network of transistors in each gate's respective complementary logic circuit. Further research will include identifying whether NAND or NOR technologies are better suited to space applications. Similarly, it is our current assumption that SLC technology is preferable for space applications, since it is less error-prone and has a longer operational lifetime. However, this assumption will need to be confirmed with further research.
This project is looking at specifically the data corruption using flash memory devices. Now, it's important to note that these radiation particles are measured by terms of long-term effects, such as total ionizing doses, or transient or single particle effects. Both are very different, and they both cause different issues. Total ionizing doses, for example, lead more to cumulative long-term damage due to the protons and the electrons. This can cause just leakage current, timing changes, functional failures, and it's measured in units of crads. Now, it's important to note these are the exact same things that the flash memory devices are working on. So any effect to these will cause issues in the flash memory drives. That's why we lead to data corruption.
Hi, my name is Hunter, and my contribution to our team's research is to share information on the 2 main categories of radiation effects. The first category being cumulative effects, which cause permanent physical damage to flash memory cells over a period of time, versus the second category being single event effects, which cause momentary disturbances to these circuits. The main focus of our project is to research single event upsets, and therefore in the coming weeks I will research and compile a list of manufacturers that make radiation hardened flash memory modules with high tolerances to single event upsets.
Hi, my name is Alexander Huffman, and the focus of my research has been on the mitigation of single event effects on flash memory. Mitigating these single event effects can be done on a hardware level with methods such as manufacturing these integrated circuits on insulated substrates such as sapphire. Mitigation can also be done on a software level using error correcting code. Multiple memory redundancy with voting is a method that utilizes both hardware and software methods in conjunction to mitigate single event effects. My focus for the future will be primarily on hardware level mitigation techniques.